Okay, number 30. Number 30 is determine the number of zeros of the polynomial function. Oh, this is UALR, final exam, college algebra review. All right, we got x cubed minus x to the sixth. The degree of the polynomial is 6. The degree determines the number of zeros, not necessarily all unique or not necessarily all real, but in this case, because the degree is 6, there are 6 zeros. The next question, 31, says find the rational zeros. Rational numbers or any number that can be written as a fraction where the numerator and denominator are both integers. It says enter your answers as a comma separated list. If an answer does not exist, enter D, N, E. All right, this one. This is not one that's easily factored because it's not a quadratic. So we need to look at it and think. We can't do it by grouping because there's not an equal number of terms. But we can look at this and say, you know what, if I plugged in 1, h of 1 would give me 1 cubed, which is 1, minus 21 times 1, which is negative 21, plus 20, and that's equal to 0. And if we know a 0, we know a factor of that polynomial. If 1 is a 0, we know x minus 1 times something is that polynomial. So we're going to divide this polynomial by x minus 1 to find out what goes in here. And so I'm going to do the synthetic division thing where I put 1 in a box and the coefficient of x cubed, the coefficient of x squared, coefficient of x, and the constant term. I bring down to 1. We did this last week. Multiply by 1 in a box. Put it over here. Add the column. Multiply by 1 again. Put it here. Get negative 20. When I add that column, multiply by 1 again. Get negative 20. And that tells me my denominator, or my remainder is 0. So in here we have x squared plus x minus 20. And that is a quadratic that we can factor. Two numbers multiply to make negative 20 and add to make positive 1 are positive 5 and negative 4. And so our zeros, our rational zeros of the function are 1, negative 5, and 4. And that's how you do number 31.